Hello, everyone. Welcome to the broadcast. Today, we're going to be continuing our game dev project. Going to see if we can get some more of the core flow in. We've got to get like loading screen, that kind of thing. Since we started the async loading and finished it since the last time. Last dev stream, we started it, and in the interim, we got it all wrangled. So we'll get to see some of that. We can actually see the game functioning in just a moment. But before we do, let's check in with kitties. We do have Ember and her in her spot. You can see some little paw socks there. Hey there, Levi. Welcome. Good to see you again. Let's see, we had one of them trot through the play area there, and we have Sky up in the tree. Let's switch on over. Let's see if camera 1 behaves for a little bit. So for one, we can see a bit of the rotation logic in play here. Again, there is a lot of new math that went into getting it to do this. It can be set to track an entity. If it does, it moves along with them. So this is the way that we'd ultimately recreate something like the Bible in similar from Vampire Survivors, is the kind of radial death. You get layers like it has at the moment because of the spread that happens. When it fans out into 3, there are a few that have effectively a tighter circle as a result, and a few that have a wider circle. So if we reduce down the number of them, and see that some are orbiting a little bit differently. It will attempt to get to particular radiuses. That's how it's set up to get the sort of circle around you, is that it will expand or contract to that point, and then it will stop. Let's set off the fireworks before we get into what we're actually going to do here. Like we mentioned in a prior one, some of these are probably going to become particle effects. Since there doesn't necessarily need to be an actual entity for the explosion, like a lingering sprite, it can just be a play this once kind of thing. We'll have to figure out how to do that, but that comes later. But shiny, shiny. So we still have all this working, and all this data is loaded up right at the start. So we'll end the program. Definitely got some... There's something stuck here. It's disconcerting. Well, I went to stop it, and it just stopped. I wonder if I just need, like, a reboot, you know? Wouldn't be the first time. So if I start this too fast, we get an error. And that's because the load isn't done yet. It takes a moment to actually load it. We can make it a little bit faster. There is an arbitrary delay that takes a moment, but right here, we waited a few seconds and it was done loading. If we look at our load up code, is it in here that we did it? We have a wait state that we introduce. I think it's in the task, so read file contents. items seem to be off. Why can I not find them? Oh, it's get file contents. Here we go. Task delay 1 full second. If we say a quarter second, let's see how quick we can get this done. Click. Okay. Immediate click is still a problem. Yeah. So we still have a bit of a delay here, or at least a failure in the process. But the time we're talking about is still to load a couple hundred files. It's to be expected that it will take a moment, if for no other reason than input-output lag. Well, yeah, like file access lag, I should say. So, if we say I can try to read the file again 4 times a second, that is still, I think, pretty good. We're going to keep trying to get it. There is some fail condition checking that I want to get in here, that if we load all of the files, if we're done reading the core files, and we still have some that cannot be found, we need a fail state. So that it stops, tells you, hey, this thing is missing. I can't finish this load. Kinda stuff. But before we do that, we want to set it up so that when we're loading files, we have a way to wait until it's done. At the moment, the catalog immediately loads its files. We need to have a way to identify that, that the load is ready. So let's look at our actual game flow again. It's been a bit since we've gotten to that. It lives in core. So we have the game. We have various screens. So we have our main menu in a game. These are going to be where we put our loading screen as well. Or this is, not these are. Here's our core logic. This is when we're starting up. We're looking at it. We're getting the command lines. This is where we actually set up our resource file. What determines how the game works. A lot of the pieces are modular. So right here we have a hard-coded path. We can make this a constant, but we'll get to that. So this is what will load if we don't find anything else. This is where we're going to look to say, is there a different startup resource path? If there is, we'll load that one instead. Otherwise, we will load the default one. So this is when we create our initial screen. This is the root of our Godot tree. And we load that up. Now, I think we're looking for ready. Yes. So first thing we're going to do is we load the main menu currently. I have a series of other events that are set up for things like the game is running, remove the game, switch screens and whatnot. Ultimately, I would like to put some sort of wrapper around this such that it is the one emitting different events based on what it's getting from other objects. But the core is currently doing that, and that's good enough for the time being. Let's see here. Let's see. We have a load game, and we are going to, for each of these, when the main menu is created, we are subscribing to 2 particular messages, the start game and the exit program. Exit program can also be triggered by the escape key. But main menu can give us these 2 things. This is kind of why I want a consolidated message structure, so that it is, I am receiving a message and I look at it and see if I care. Because then we can have things emitting messages kind of broadly. Hey, if you get this message and you exist, do this thing. But each individual one doesn't necessarily need to do that. But core currently is the one that orchestrates everything. So we load the main menu. If I click on the start button in the main menu, let's get that screen up here. So we have our start button that's wired into it. We have our start and end button presses. If our start button presses, we're going to do the start game. So we're going to invoke that message. The main menu, or the core, which is subscribed to that message, is going to react to that. We're going to get our on start game from main menu. We're going to pull the main menu down and we're going to put the game screen in place. So we get what the game screen should be. We subscribe to its the game is over option, and we put that one on there. Similarly, with the main menu going away, we pull it off the tree. So if we go over to Godot, I'll actually see if it explodes in Godot too. I haven't run it on the Godot side recently. That is a disconcertingly slow build. Well, it got there. Okay, so if we switch over to the Godot side, we're going to look at our remote tree. This is what the tree looks like while we're running. We have our color rectangle, which is in the center of the screen, just so we know where the center of the screen is as far as the game world. Our main menu is currently active. We have our start and end buttons. If I then go into the game, we look back over, and now the main menu is gone. We have the game. We have our camera. We have our little debugging stuff. We have a bunch of things that exist in space, as well as the entity manager that just hangs out. All of these currently live in the Godot layer because how we want to swap them out. The entity manager, all of these are defined in a resource file, which means they need to be Godot resource objects, which generally means they need to be scenes. It's fiddly. I could probably set some of them up differently, but this is how it works for now. Then if we go back into our game and I escape back out, escape being a hotkey inside the game object that also counts for drop back to the main menu, we can see our main menu is back. We have our start and end. So part of what we're going to add to that loop today, if I don't get totally distracted like I usually do, is to go in and say, okay, before main menu, there's going to be a loading screen. And that loading screen is there to ensure that the actual game load happens. At the moment, it's only going to care about, hey driver, welcome. So at the moment, it's only going to care about the catalog, so we don't have to worry that we're going to hit start too soon. Like, main menu and all that won't appear until the game is actually loaded. So for that, we're going to need a couple of things. Let's go over into the Visual Studio side so we can get these organized cleanly. We're going to have loading. And we're going to add a new C# class. Let's check that first. We're actually going to call you loading, or, well, we'll call you loading. There we go. That's fine. We're gonna redo that so that we spell it correctly as opposed to layouting. Just so. And it lives in the global namespace for my project instead. We do tasks. Just showing everybody we got the game actually functional again. And our current issue is that we're showing the main menu before the loading is actually complete. You know, even if we're waiting a quarter second between trying to finish loading a file to make sure all its dependencies are loaded, that can still add up across a very complicated catalog base. So instead, we're going to get a loading screen in place so that for now we can load all the catalog and whatnot, but that may eventually include things like getting shaders baked, you know? Hey, Dodds! Yeah, effectively splash screen time. So if we look at our main menu extends a canvas layer, and that's pretty much what we want. Canvas layer in Godot is essentially a screen overlay. Like Node 2D and whatnot exists in world space. So like you could move the camera away from it. A canvas layer sits on top of the screen. So if you slide the camera around, that canvas layer still sits there. Generally. Okay, let's see. Let's get that ready in there, just in case. Yes, and that's actually how we're doing the number of entities ticker inside the game. Those are labels sitting in the HUD, so that I don't have to worry about constantly sliding them around. Okie doke. What are we doing? Okay, we need to make sure that the catalog has actually loaded during this. Right now, the catalog is told to load immediately. As soon as it comes into existence, it tries to read. We could delay that to here. And have an explicit load to where once this enters the tree, once the loading screen enters the tree, that's when we set up the catalog. And I think that's reasonable, because then we have control over the flow. We have firmer control over the flow of things. Otherwise, the catalog kind of springs into existence pretty quickly. Just cough. Okay, so let's look at our catalog here. It's part of the game data. Like, it's loaded as part of the game, but I think ultimately catalog is going to end up living outside of the game. Extends catalog extends node. It extends node because it kind of needs to. The reason I'm pondering this is because the catalog doesn't actually spring into existence until we have it ready. Let's show that. So we have the concept of the global services entity. And it's the thing that is priming all of this stuff. We have a bunch of classes, essentially, or node types that the services is going to prep. And these will be the things that we use. So what kind of entity manager, how we render the map. All of those are prepared by the game services object. All these little guys. So catalog does live up here. It's only loaded in as a node in the game tree, but it doesn't actually have to. Let me look at that. There are several things that are kind of vestigial from prior implementations. So if we go into our remote tree, we don't see it there. We start into our game. We look at our remote tree. Correct. Catalog is not loaded as a child. It really does need to be pulled outside of the game folder for organizational purposes. Like, it is not part of the game screen. It is part of startup resources or the core. It doesn't matter that it lives in a folder here. But anyway, okay, that makes me feel better about the loading screen being the one that calls the load there. So base catalog, we have some of these get functions or copies. Let's see. We can add an explicit load call here, such that once we have initialized it, we could run that way. Alternately, since the catalog is loading that right away as soon as it comes into existence, we could have a property on it that says I'm done loading. So right now in our load files, we're going to go to the definition there. We get all of the directory content. That's not going to be done until ultimately this completes, and it's going to be in a wait state to get there. So we could have a... no, we're going to put this up in the parent. Let's see. Of a... does need a set, but we're going to have a protected inside it. Okay. Was unfamiliar. We've created a property, but what that property does is it actually interacts with this protected variable. So outside of a catalog, you can only ask if the loaded state is true. You're going to ask, what is the state of loaded? We can't actually edit it from outside, because this one is only allowed to be touched by the class and its children. So at the end of load files, after we get directory file content, let's see, let's go to that. We could do an event, but we can't be certain in loading when that event happens. If we move the load files outside of the constructor of the catalog and only do it during the loading screen, then we could have an event that says, "Are you done?" And thinking on it, I kind of like that. We could move load files to be part of the core interface, and just have a event on this that we could subscribe to that is loading done. Though, waffle. So if we do it this way, then each call, we would need to make sure that this is an async function so that we could await the results of all of the different loading that we do. And we could do it in big chunks. We could have events that get raised on each of the catalog's load completes, or each of the load complete objects. So we tell the catalog, hey, load your stuff. And we do that as a task so that we can wait for that to finish. We prep the task for all the loads that we can do at once, and we await their result. So the loading screen can sit there updating, showing stuff. Perhaps a meter that will totally be accurate. And have that run. It gets done. The task is completed. We could assume that because the tasks are complete, we can proceed. But if we have events off of them, then we can update the HUD, or we can update the visuals on the loading screen according to what is done. Again, whether that's just a bar filling up or something else. Perhaps text. Yeah, let's do that. Let's do that. I like that better than the proposed initial change. Godot, please stop doing that. Okay, let's... These import changes are because I had not loaded Godot since I renamed a bunch of these files to ensure that the file names were unique. That will be less of an issue once I have a single core CSV for my edits. But in the interim, every time I change like the name of a file or where it's located, Godot will re-import it and we will get stuff like this. It's like bleh. Those you pushed up there. We don't need to keep that change or this change. We're going to keep these around. That in there. And then we can discard these. Because we're going to do that different. Can I get away with that? By just declaring it async. When I override it, can it be async? Or is that going to cause problems? Okay, yeah. I can declare that this version of it is asynchronous. Because I don't really... I'm just going to call the load. And it should relinquish control. I don't really like that. I mean, most of these don't actually have to be abstract anymore. Gonna step away for a moment. I will be right back, and then we'll continue. I was attempting to find the hockey puck for Mason's little air hockey table, but Molly has hidden it in a different spot this time. And I don't know where that is. We'll have to see later. Hello, Ember. Because I want to make this a task to run this thing. Should be okay based on we did file contents. That is an async as well. So we could make it a virtual and have this do nothing. The reason this is abstract is to force child classes to implement them. As in, these do nothing without that. But there's nothing that says this can't be a regular class with a bunch of virtual methods, and virtuals are just override them, you know? So I could do like that. For all of these is effectively, if you try to interact with one that is just a catalog, you're going to get nothing. which means it wouldn't work, but frankly, the only reason I would implement another catalog is for testing purposes, as opposed to the base catalog. Would be for testing purposes or for hypothetical like updates, so that I could be building the new one without having my branch constantly in a non-functional state. So if we change all of these to virtual, then we should be able to do a virtual async. Such that when the loading screen calls load, it can call it either in a task or in an await state. It's going to complain about that, right? Yeah. Yeah. I don't want a class. Want. Oh. Oh, that's why. I was using regular paran, so it assumed I was trying to input parameters. Weird assumption, but... those... So again, if you don't implement these, they're not going to work. They will not do what you want them to do, because you're going to say, hey, give me the one that has this identifier. It should have that identifier, but you're not getting anything back. If I wanted to make a test catalog, what I could do is have a bunch of hard-coded values, such that I could test if I load a string that doesn't match the hard-coded value, I don't get one back. If I do, I get the one back that I expect. And so on. So now I can implement load in base catalog here. And we can have load files be async as well. I could just call you load files, but we'll call it load. Right here. Copy that, get rid of you. Hello, Zuto. Get directory is that, so we're going to await that. Would be a task.run then, wouldn't it? I would expect a task return. Syntax. Yeah, okay. Okay. But in any event, welcome, Zuto. We're working on our game. loading, at the beginning, we are going to do services.catalog.load. We can just do services.catalog.load. Within that, it will be asynchronous. But we would set this up as a series of tasks. Be able to do task.run. That. Await all load catalog. So as soon as this one is ready, it is going to wait for this task to complete. So all of its children will be active. We can have an event on the base catalog that we can raise when it's completed so that this can be looking for that information. We can register the event here, and then when when the loading screen sees that event fire, we can make updates to it. We could also wrap this as a series of them such that when one of them is done, like I could have a wrapper task for services.load that says when this is complete, I do an update. Let's do that. As we're loading them all at once, they're not going in sequence. If they're, sorry, we don't need them to have a what I'm doing. We need them to have a when I'm done. So we do that, and then we're going to run this in here. Catalog. Ask. So load catalog is going to wait for this one to be done, and when it is done, it's going to do a thing. So for the interim, we do that. This dot add load catalog. Hello, Sky. Molly has joined my footrest. Sky has climbed onto my lap. Kind of waiting for Sherbet to jump on my headrest and Ember to try to crawl onto my shoulder. Complete cat debilitation. All right, let's see here. Task list. I'll take a list. This will make it so that we can be a little more flexible. We can create a series of events here. So if we have to load them in sequence, we can do individual task, wait for it, individual task, wait for it, and move on to the next one. If we can load them all at once, we stuff them all in the list and wait for them all at once. Iterate as needed. For now, it's just loading the task. So the loading screen only exists long enough for everything to load. That is its whole gimmick. Molly is squirming her way onto my blanket, which means she is only supported by the surface tension of the blanket as it is held under my legs. If she wriggles too much further, her position will cause her weight to dislodge that. And then we have the slow descent of the cat as the blanket is pulled clear. Indeed, cat physics. Molly has a lot of kitten energy, and she is my least coordinated cat. It's not that, like, you know, she runs into stuff. It's more that she's not as good as that intrinsic cat movement physics, you know? She gets her math wrong. Alright, so we have our loading event, but what we're just going to do for now is need a syntax. Public delegate. And then a public event that is of that type. And inside that, we have a public event. Loading done, onloading done. This is onloading done. If there's anything in it, we invoke it. Huzzah. So this is full loading done. I could have other events set up to be emitted as, like, hey, this part of loading is done, other stuff could happen. But for now, we shan't. Okie dokie. So let's look for our screens. You can see here some of my prior tests. This is a collision system that was entirely based on brute force in the shader, in a compute shader run on the graphics card. Remember which one we're using right now, actually. I think, okay, yeah, mass physics server based is we are only talking to the physics server and we are creating a series of shapes in different areas and checking for collision there. So the shader based one is functional, but it only allows us to do very limited style collision checks without more math, and it's fiddly to get the data in and out. Because you have to pass things to shaders, and shaders have a very particular way to do that. We are currently doing node-based, which is default Godot stuff. Originally, when we were doing our testing, this was very low performance, but we're still getting pretty solid performance right now. I don't know what changed, but I'm fine with it working. World state. There's our main menu. So we're just, it's a canvas layer, so all we need is another one like that. And it extends another type of node. It's going to extend a canvas layer. And it is going to be loading. Then we are going to pin a script to it, which is our loading CS, right here. And in our core, when we start up, right now we're doing load main menu. We are going to have a load loading. Oh, Vapid. Void. And currently we have detected loading. Loading. Set up our loading screen in our services. UI world state. No? Where did I put that? Startup resources, main menu. Yeah, here we are. Here we are. You're in the way, Sky. Public packed scene. Loading. Okay, now we go over to the Godot side, and we're going to find our startup resource, our default startup resource. So we have our catalog. Here is our, let's build that. There's our loading. So we have back on down here. So we have our main menu scene. We have our loading scene. We take loading, stuff you right there. So we have a packed scene, a Godot scene file that we have access to now through this property. So core, we do loading, services dot startup resource. Hey, John Doe. Well, I hope the stream ends up being worth it for you for an early wake up. Instantiate. 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 And that is going to be as a loading. I'm going to reach around a cat here. Loading done plus equals to loading unloading done, but we are going to change that. Something else in a moment. I'm just going to say that that is unloading done. Child loading. These are okay. unload loading. Is pretty much the same general pattern. So if we have a loading screen already, we're going to detach the events, remove it as a child, and null the variable. Loading is not null. We say loading dot loading done minus equals that. Child loading is equal to null. So load loading, unload loading, on loading done, we are going to say unload loading. Then we're going to do a load main menu. And we have load main menu, we have our on exit program and start game. Is already. Loading. And this will totally work first try. Didn't work first try. Oh, no, it did. It did. But we did have a blocking spin there. We are going to need to have some different logic there. Our loading screen, we fire it up, we're going to await the task, but that's in ready. Maybe that's part of our problem. We could do it on a first tick, like wait for the screen to begin and let the rest of the thread continue. I think it's because we put it in ready. Because we could do it in process once. Let's started for now. Yeah. Not started. There's a wide range of options there, John Doe. I mean, software development is a pretty wide field. A very wide field. That work? I think part of our problem is that these aren't async methods. Wait. No, we want to do it here. When we call load catalog. Well, that's what we're doing. Gonna have to figure out where I can call this effectively. Oh. Simultaneously, to try get value, we had something mess with the catalog. Which, for our purposes, isn't really a bad thing, because if I don't get it, we're just going to try again in a moment. If I do get it, it's then fine. But there is the possibility that I get a overridden version. That is going to potentially cause problems down the road, but we'll think about that later. This whole async model is causing problems already. So we are very quickly drifting back into just load them in order, but because thinking on it, if I make this modifiable, like I have a subsequent folder that I can load and say, hey, you can override values in this. I could take the player and swap them out for a different player in the modded file. But if subsequently something in the modded file references the player, if the player referencing one loads before the new player one, it will get a copy of the old player. Oof. Oof. It's already become an issue. All right, how are we going to solve this to begin with, though? One thing at a time. Is there a way... Is there a way to lock it, essentially? That's... Checking. Current dictionary. Okay. Update. Your complaint. I don't know that that'll work. This is expecting a factory model, which I don't have. Could set up a kind of mutex structure. As any number of things can read, but only a few things can add. Checking. Checking. Let's try that. Mutex. New. It's not a read lock, that's a write lock. Noise. Text.wait, and then release. Until then, waiting for our turn, and then we're done with it. Okay, so that blank period is our loading screen. Again, let's put something on the loading screen so we can see it. A menu has a box container. Let's get a label. Just for quick reference. Should in the upper left-hand corner say loading, but nope. Oh, sorry there, Dodds. I didn't update. Stupid. Fixing. That could explain a lot. I have to manually update Twitch for that kind of thing. I can set it up to be, you know, with YouTube, you set it up in advance and it works, but I have to go in and, like, type it in before each stream, you know? Okay, why did I not see the loading appear here? Because the loading screen should be visible during that time. Like, we shouldn't be blocking during it. I mean, ideally, we'll have a lot of keyboard hotkeys, you know? No worry, Dodds. I appreciate you calling it out. Loading, and then we're going to hit the first visual process step. But why in loading does this seem to choke out? Because this wait all should allow it to continue, but it might be that process doesn't work that way. We could have... could have a continue with on it. Which would take... get the task object in, but... What I'm thinking is, could we just have... Can we set up just a callback on it and let it go? I wonder if having the await here is part of our problem. Because I could have like a loop in process that, you know, asks the catalog, are you loaded? Seems a bit wonky. But we're not much better off here. Because we're not loading any of the UI. Could I change this to... all that. Oh, okay, no, we don't have anything but physics process for a canvas layer. Sorry, we don't have anything but process. There's only drawing that is done. Well, no, it says physics process right there. Why you know? What's purple underline mean? Oh, because code is running. It doesn't help us if we don't have... If we have to sit there and wait, it's not doing anything for us. Syncing away, yeah. Okay. Let me sync. Says it's going to run synchronously because it is not. All right, what are we doing in the catalog that we were doing differently? It was in the git directory file contents, I believe. So await when all. Loading. Okay. Again, we now have the loading screen in. So this is the period when we are actually reading our data files. Part of the problem here now is, I think we can move that elsewhere, but I think process and physics process was the only thing. Methods. checking where you can use it. Document real quick here. I'm trying to figure out which methods I have access to as asynchronous, and I think they're still the frame ones only. Overall, this should be okay. We're gonna try this. Whoops. Well, that'll never end. Loading screen only unloads if the loading completes. Okay, works the same way. We can wait for the ready to happen. It's not ready until we're done doing all of this, but we're going to do it asynchronously. So then in our catalog here, if we change it to 10 times a second. That made it worse. Yeah, that made it worse. There's a threshold here. If I ask too often, then I am I'm running into kind of contention here as far as how quickly it waits. So we get a value out of read file. If we get a value out of read file and it is, then we're going to go in and we're going to do a write lock. And we're going to query it and see if we can add it into the catalog. That shouldn't be tying up so often. Okay, yeah, this can fail if it doesn't get it. And that should be okay for us to delay at that point. As in, I got a catalogable. We're only doing the write lock to avoid write contention here. Confusing. We have made progress for the loading screen, at least. Okay, let us do a little bit more here. So in loading, we have a label here. Let's do some fiddling with this for its alignment. centered. We're going to go into our label settings, or is it our that should be might be under label settings. Let's make a label settings, line spacing, font. Okay. Loading. Then in our code, we are going to export that label. We have an object for that. Add menu bar, progress bar. Get rid of our loading label. It's okay. Yes, progress bar. Its layout is going to be center. Min max 100. We won't have a way to know that it's, you know, full 100%, but is there a way to get it to be differently sized? That's our size transform, but I don't know if that's what we want. Okay. That is, our transform is what we want. We do need you centered. So our transform is not actually what we want here. Not for that one. Hello, Ragnarok. Hello. Interesting. What does that even look like? Might have to give it a parent object to anchor it properly. Really feels like layout is not, doesn't have a control parent. Okay, let's... We need something to put this in. A tab container. It could just be a generic container. But we'll do a vertical box here. Its layout will be centered. Center, and progress bar is inside vertical box. Progress bar. Cannot do a size transform on it now. That's because its parent container, I think, is where we're getting that. the anchoring of it seems weird that it's doing that, because our central anchor is here, but we want it to have... I mean, welcome to Godot, as far as the visual editor. So if I go into the VBox container and I give its size something else, it stretches right. I don't want it to stretch right. I want it to keep its anchor position. But how do? What did I do with the buttons? Size, it is anchored center. Okay. So why does this work differently? So that's our actual position here. That should be accounting for an offset already. So we're not even properly centered yet. Center anchor is still right there at the left side of the screen. Okay, I could move it to here. And say... it's janky as all get out, but hey, whatever. It's 960, half the screen. Then it's height here. Let's actually revert that. I'm going to put them all the way back. We're going to change it from custom to center again. We're going to go into the progress bar, and we're going to try to change its transform now. Oh, okay, we can. Noted. UI editing can be a hassle. So then we're going to take our anchor, put that there, and we are going to center it. There's our progress bar. Okay. We're not doing anything with the progress bar yet. It would only update pretty much when we're done here. Okay. So now when we load in, our data's all set. And everything's rolling. Okay. Let's see. Next, I want a game end state, and that's where things I think are going to get a little flakier, because the game scene then needs to be listening for the player state. If the player state says I'm gone, I'm done, then we need to report that to the game state. The game state is going to say either it's going to swap in a scene for itself. I'm thinking that might be the case because we do have examples in other games in this genre where you will get a game over screen. You have been defeated, but you have the choice of, like, do you want to revive kind of stuff. If the game over screen is separate of the game screen, then we wouldn't be able to pull that off. But if the game over screen is part of the game itself, then we could do that, because then the game just has to freeze itself while it shows the game over screen. And then it can decide whether you want to be done or not. Because we already have logic for bailing out of the game screen. That's straightforward enough. Okay. Okay. We'll be back in just a moment, and then we'll continue along that concept. Let's get that game over screen wired in. We're back. Let us... We'll add a little bit to this. Interesting to periodically query the catalog and see how much is loaded, but that doesn't actually tell us anything. Okay, anyway, let's get a game over screen in place here. I think we're going to go a canvas item again. Public. Layer. Then this one is going to have an event for We would need a way to decide if you would continue. Then we're going to need UI elements on the screen that are buttons in the same way as we have them on the other. So we're going to go over here. We're going to get to our game state, which will now have a game over folder. I'm going to add a new scene, which is game over, and it is going to be a canvas layer as well. We're going to attach a script to the top node here, which will be gameover.cs. Ta-da! Add a resource, add a child node, which is another box container here, which will not be how we actually do this, but in that other one. Used a button. Why different? Oh, used just a button. Select the button, call it end. Okay, we're going to give this like a third of the screen in size. We'll just do a simpler one. 360. Okay, then this will align center. Just so. And these have to be adjusted to fill the space. This one is going to be... Okay, found the option for that. Container sizing expand to fit. Okay, we can do the same thing over on loading then. You are not going to have a custom minimum size. Instead, we're going to use container sizing. Just so. Fill the space. Okay. So then over in our game over screen code, we are going to have exports here for the continue and end button. Nope, not here, in the class. Export it. Export it. Back into the Godot side, rebuild the C# project so that we now have that. Build, continue button, end button. Just so. Okay, now we have those. Public override, ready. When it is ready, these values will be filled in. Until it is ready, these values are not filled in. You have to watch out for that. Button dot. All right, what do we use in main menu? Pressed. Makes too much sense. This equals and button pressed. Okay. This one we are going to be on end game. If it exists, we're going to invoke it. We are relaying the event, essentially. So, all the continue screen does is give us an option to bail out. So then in our game logic, we need a way to detect that the player state says the player is done. Handle a health change. Say the player is not alive. Where do we remove the player? Here we go. This is removal of the player. What we can do here is add player state is a node 2D. Doesn't actually need to be a node 2D. This could just be a node. But what we're interested in is the tick to send the message. died, on player died. Whatever we need to do to raise this message gets handled in the implementations of that class. What do we use alive? Yeah, we might reference it elsewhere, but for the time being, end step message, which is where we should be doing that kind of thing. It's a bit of an order of operations fiddliness here, though. With this particular handle message, if not alive, say on player died. If it exists, we're going to invoke it. Why? It's obnoxious. Yeah, it's virtual. It's not a parent class, it's an inherited class on Node 2D. Okay. Virtual methods. Not abstracted, so we should be able to do what we want with them. Okay. That's weird. Aren't we doing this elsewhere? Doing that directly here. Yeah, okay, that's what's going on. So for us to have this, the player state needs it. And if the player state is going to have it, we need... default, all this does is on player died dot invoke are protected. Then in our base player state, we are going to raise player died. Okay. Okay that we would skip that. Could do it as part of a physics update down here. Where we get the next tick. we'll just raise it here for now. Okay, so if the player is removed, we're going to raise player died. In the game state, we have this player update here. Well, we're calling the update. So we have our player state set up here. We can... adding a child for the player state. If we do this, we need to clean up at the end. Where when we exit the tree, we need to detach from this. But because this player state can linger is the thing. Which we don't really want. All of these should be reinstantiated when we need them. Like, there's no reason for me to keep an entity manager around. Oh. They said there's a lot of code that is still hanging out from when we were doing things a little differently, and it's suddenly running into them and being like, oh dear. We're doing it that way? Oh no. So, a base entity manager, are we doing anything to clean up? So we have an exit tree, but we're not doing anything with it. We should clean it out. We should clean out all of our corresponding events as well. We don't, because the entity manager doesn't intrinsically do that? That's weird. It should. Entity manager has an entity added. Okay, yeah, and we raise it here. Raise entity added. Okay, okay. We're doing the same thing there. We clear our entities. Doing that in our base entity manager? Doesn't look like it. I'm thinking on this because when the game ends, there's got to be something where we purge all of the content. Just invoke end game, and we remove the whole game. But where in the base entity manager do we acknowledge that we should be getting rid of everything? I mean, world state might be handling that. State. Nope, world state's just emitting everything. Okay. That feeling when you've forgotten where you put things, you know? Where do we purge everything each time then? Services cleanup is only when you exit the tree. Do we make an entity manager? Core is not where we load those sort of resources, just a thing, services. No. I know here we've got to at least instantiate the main menu and loading and all that. Okay, we instantiate a loading here. Let's go into game. Add each of these, which is in services. There's got to be a point at which we're initializing the services. This is where we're calling prepare game services. We instantiate each of them. Entity manager doesn't get add the game. We instantiate a game. We load the child, and then in the game object, during our ready, we call prepare game services, and then we add the child. So when these leave, they should cease to exist. When we instantiate, we make new ones. Okay. That's how we're dodging this, is that all of these entities just cease to be. All of this just ceases to be. So we're going to need to preserve a couple of the objects here in order to operate properly. We need to get the player state. Player state equal to services.player_state. Add, we just do player state here. State not on player died plus equals Void on player died. This is where we're going to trigger the game over screen. And game over is going to be we need to go into our startup resource and we need to add a packed scene for this. Click packed scene over semicolon. Okay, so now we have that. We are going to go over here and say over.instantiate as a game over. So we have this available to us. So in our process and in our, we are going to need to relay some things here. Okay, here's our physics process. We're going to set paused when we show that menu. Affected. Played. Load. Game over. Okay, and we're going to say we can do this here. Game over dot on continue game plus equals that. On end game equals that. You can do this when you load it up, and I should, but I didn't. Child game over. And then in our unload game over, say game over is null. Then we are going to say that on end game, remove that. And we're going to remove child game over, and game over is equal to null. So if it's loaded, unload it. In both of these cases, we unload game over. And we're going to set it to paused. We unpause. And if we have on end game, that's when we're going to raise the end game event. We don't actually need to do this. If the pause screen is there and we end the game, then we just drop right out of the pause screen. From a practical perspective, all of the benefits of anything that would be shown on the end screen should already be applied before you can press the button. So if, like, I got tokens for finishing a game one way or the other, I should have those tokens before I take action. But we'll see. We'll see. But this is a place that we could invoke that. Okay, and we're still going to respect the escape press here. Prison escape break minigame. That could be interesting, Lunar. Alright, we are going to make it so that these are on impact to make it less likely that we stop anything from getting to us. Less likely, but not impossible. I could change the scripting so that it is easier for the blobs to reach us. I might have to. For the purposes of our testing. I have the blobs spawning less frequently, so I was able to see the behavior of the spiral better. Okay. That's why. Fixable. We are going to do that change, though, so I can make this testing easier. Containing folder. Jump down to here, jump into data. It's in spawners right now. Spawner enemy blob around player currently spawns at 1 entity per second. We'll just do 0.1. Then we go over into the Godot side. We compile C#. We need to go into our default startup resource. And we need to fill in game over, which is down here. Boop. Start this up. Loading. Took remarkably long to load, but again, to some extent that's our fault. I might have to completely revisit our loading architecture once more. Now, you can see that explosion repeats because it's just a sprite playing in a loop. It's part of the reason that I want to fix those. These shouldn't be transparent, but if I continue, the player disappears and the game continues. So we'll do that again and we'll end, which should drop us back to the main menu. Will actually be very hard for the blobs to reach us unless we do this. They can, but they'll get purged very quickly. And we're back to the start screen. Isn't that neat? So with that, we have created our full game loop here. You appear, you can do stuff. I mean, technically there's no victory condition, but this kind of game doesn't actually need one. You can just get overwhelmed and lose. So I can choose to continue, where we could have logic that says, okay, player state, revive the player. We are getting a reset. That might be ultimately controlled in the player state. We'll have to see. But we can end, you drop back, we can exit the game. Good times. Let's do a quick commit on that. This is all reasonable, I think, to jam in at once. Since I forgot where some of it is. Good enough. Okay, we've still got some crudeness to it. Next thing is probably going to be some sort of scoring mechanic. In terms of like your vampire survivors, your scoring is generally like a level. I don't know if I want to still do levels mid-round. I like the idea of having a branching path level navigation. So go in, complete a level or challenge, move on to the next one, with upgrades and whatnot happening between levels, and having that be where you mess with your weapons, you know? So instead of the grid O items being something that you invoke during gameplay of a level, it's something that you get between rounds to say, like, build your equipment, you know? You go in, we have a short burst level. Yeah, that kind of path where it is, you know, choose which area you're going to. All of them would have the equivalent of mess with your weapon on your way, but you might still have some where it is, hey, this is a downtime. You might get something different. So the scoring mechanic would be like accumulating points. And that's where we need a better identity for a game state in here. So we have a lot of maintenance stuff, like the player died, show the game over, remove the game over, deal with the end game state stuff, prepare the screen, do the basic tick updates. Yeah, the mechanism of getting to the next place, I think, needn't be a map screen. You might not be presented with a whole map. It might be an arbitrary choice that is within limited context. Like, you are presented with 3 choices. Make your choice, not look at the map and pick the path that you want. Which would let you be arbitrary about how you present it. Like, I can present you with as many choices as I want at any time without having to worry about map navigation. There are merits to those things. Okay, so Entity Manager is entirely... Okay. So the next thing I would like to do is set it up so that we are in some way tracking what happens with the player. If we go with the route of... So the standard thing with this kind of game is essentially points drop on the ground. If you beat an enemy, there is some chance that they will drop a point. You get that point, and it gives you some number of XP or score or whatever. You get enough of them, and you get a cookie. One of my annoyances with that model is that inevitably there is a pickup radius. There's how close you have to get to them to get them. and a core element of the game is to pick them up. So you frequently get upgrades that are things like you can pick them up from further away, that kind of thing. I don't like it because it feels obligatory. Like your entire power loop is centered around those, and having a finite upgrade that picks them up from further away doesn't necessarily feel good, especially given that they drop randomly and they're the whole point that you're killing the things aside from survival. But either way, what's your thought, Tass? What's your thought? One possibility would just be when the enemies go down, we raise an event. Oh, we got Sherbet on the bed, I just noticed. The two brothers are snoozing. That would be interesting. Even if you don't swap out to the thing, having it be a default additional weapon. Like, if we assume that pickup is an upgradable thing. Ooh. That could be neat. That could be neat. If it's effectively a projectile, you know? Then your pickup method is whatever you build it to be. Could be visual clutter, but I think there's merit there. The plus side of this is that I think the starting point is the same no matter what. And that's that we have some sort of detector that says you are close enough to get it. And that is likely to be an entity that pulses periodically, very quickly, like multiple times a second. And it says, I hit pickups. Like, I hit doodads you can pick up. If I want it to be universal, I just make the radius gigantic, and anything you kill, its pickup is probably going to be snapped up right away. But it comes down to the hitbox that it strikes. And the XP doodads would have a hitbox. So we are, for the most part, creating another weapon, whether it is something that you can see and modify in your toolkit, or it's something that is effectively invisible and works behind the scenes. Doesn't matter. We can get to that later. Okay, so that would necessitate creating an entity that has a particular type that we haven't defined yet. I mean, technically we have. Let's... Oh, no, actually, we didn't get around to that. But we can. So we can set a type here. We can have a type of 8, which would be like points. I would say that we're not going to say it's a pickup, because if we put doodads on the field that are like, blow up all the enemies, sometimes you don't want to pick them up immediately. Sometimes you want to linger near them and walk over them when you're ready to use it, kind of thing. Yeah, bridge strong. Ow. Yeah, Lunar, if we go with an old school method of just the kill gives you XP immediately, then ow. If we just give you the XP immediately, then we make it so that the thing that gives you XP that is emitted is, yes. Oh. Let's see if I can drink this properly. Almost messed it up again. Ow. If we get the XP immediately, we change the visual of the item that gives you XP to just be like it emits a particle over where it was that says +1 XP or something like that. And you don't see the doodad that you collected. Like, we can choose to have the things hoovered in so that the XP, like, converges on you. Again, the classic model, your Vampire Survivors model, where there is a token that gets sucked in. We could have them so they disappear immediately. Like, if it's in radius, it just gets picked up. And you get a little sparkle in points. Yeah. So the reason that you have to pick up the XP is worthwhile is that it encourages the player to move. A small XP gather radius means you have to be walking around constantly. But if your power increases enough, walk around constantly generally just means walk in a circle. You are not encouraged to explore. So that's why we'll be playing with this. This is going to be a fine-tuning thing, which merits the idea that these are separate from a pickup. For reference, this is a bit field right now. It doesn't actually have to be. No, actually, this has to be. This must be a bit field. Right now, nothing is multiple types. This is a bit field because of collision layering. Right. It's the smaller your pickup radius, the more you have to move to go grab what you get. The larger your pickup radius, the less you have to move. And that's why you aren't really encouraged to explore with a pickup radius. You're encouraged to move as much as necessary. And that might be not at all. If we want exploration, then there has to be a reason for you to go other places, which might mean that you don't get points for kills, you get points for getting to places or finding things, which is one of the things that I wanted to do, is that the points that you use to get resources, or the points that are resources, whatever, just because this is listed as one thing as points does not mean there could be dozens of different tokens that count as points, but they do different things, you know? You know, I need sprockets and I need wires. They do different stuff, but I want both of them. Kind of thing. Is that in the field, there might be a series of things that I can do or reach that would give me points. that I could use to do upgrades, one way or another. As such, I want to move around the map. The enemies impede my ability to move around the map, and I want to move around the map because I get points. So I use weaponry to get rid of the enemies that impede my progress. Yep, you could have like unlocks, you could have currencies, you could have all kinds of stuff scattered around the field in different ways. So you want to trot around and get them. It also allows us to have very different level types. You could indeed have a level type where all of the points come from the enemies. And your goal is to smash as many enemies as possible during that battle, while still surviving. You have others where, hey, you have to constantly move to the right and, flee a tidal wave, but you get points along the way. Kind of stuff. That gives us flexibility. I like that. Okay, so that's going to mean we need two things. Well, we need one thing to start with, and that's we need spawning logic that creates doodads. Well, we need a doodad. We need a thing that is a point. We've got a lot of options for how we're going to be able to do this. I'm very interested. Okay, we need... copy you. We'll call it a point, and let's call it a test point for now. It's an entity type. It is a category. What do we say? It is a category 8. We'll use a different one. We're going to use a different model for it. I think we can use like laser dot for that. So this bullet red dot, we need texture for that. That is going to be sprite for bullet red dot. This song and dance I'm doing with folders is the reason that I want to consolidate these down to a CSV. I want to be able to just search for stuff. Okay, now we have group enemy base here. We don't want this to be... It will not retaliate in any way. We just need it to collide with the player and go away. So, do we still have a self-destruct behavior? We have kill target. We don't want that. I mean, we could, but that would mean the player has to react to the event. Or the tokens would have to do that. It's not a terrible idea for the points to be the ones that control it. But this would require the player to have collision kill target set up. This is the player gets run into. Punch through. We need a new one then. Points will likely have a special type to them, you know? They extend behavior. So I will likely have collision points be a parent class. And they will add a property that tells us what kind of point they are. Message. Actually want to do that. Oh. Okay, so this is we need to check if it is what kind of collision message it is. Tell that one to handle it. Let's do fake collision health. There we go. This is our current health. Change target health. Copy constructor will need that. Okay, we need a copy constructor in place. Do that. We'll call base. Zoppy. Shoppy. Is collision points. Collision points of copy. Then we would do stuff with that. I don't have any variables set yet, but if I do any of them, I'm going to need to do this anyway. So for the time being, we do it that way. All right, so then we don't care about waiting. We want a collision message. We can end step it to make them go away, but for the time being, we're going to just do this. Don't think we need the base handle message. Yeah. Do not eat the message, is what we're saying. Message is a collision message. We get who we're colliding with. And the relevance of this will be deciding if the player collides with power-ups or if the power-ups collide with the player. I kind of like the idea that the power-ups will declare what they do. We don't need to consult the player object as to what to do with them. And target is player entity. Okay, we are colliding. Our target is a player entity. These are the things we care about. We are not going to inflict a health change. We are going to add points. Okay, so this gives us a collision points type. It means that the logic for all of the behaviors of different points would be smushed into the player. So I would have to have code that says, oh, you got a points message. That means do this with points. You got a invincibility message. Do this. Saying that makes me feel like we should, as far as the player state. Because player state does all the message handling for the player. But no, that's okay. That's okay. Because the point is going to throw a message at the player. If the player is going to be made invulnerable for a period, it throws a message and the player knows how to add invulnerability. But the points might be handled outside of the player. They're a separate system, you know? There's nothing about the player entity that has like hit points and whatnot that necessarily cares that it's holding 3 points. Like that could be a score box kind of thing. The whole point of this is to handle the actual player object on screen. As in, does it take damage when it gets hit? What does it do when it takes damage? We can throw it at the player, but we don't have to. Okay. In that vein, we can actually verify how this works. So, we need a collision change target health. We're going to look at that. It's going to send a health message with the health change. We are going to send a positive health change to the player when this happens. Is this what's going to happen? Absolutely not. That's not what it do. 1. Add 1 HP. Okay, so now we have a collision points. Should be spelled like that. So we have a type of entity. That's for our point. And then we look in our behaviors. We have collision types, and we're going to say, just going to look at player hit. Okay, collision points. So we need a collision behavior rigged up for this. Points. Points, not collision bounce, it's collision points. There is no bounce count. There is no gate. We don't need to worry about any of that. And inside of collision points, once we send that, we're going to say services, entity manager. Move entity. I am the one that detected a collision. The collision was with this thing. When entity detected a collision with target, send a message to target and get rid of entity in the next frame. Player, then done is true. Not done. And let's do it as a wrapper. November. Hello. Hello. This is fires once. Once it has had one collision with the player, it's done forever. That way we don't get the risk of a multi-collision on the next frame. So this is demonstrating what we can do. It's if we want to throw at the player state, we throw at the player state. If we want to do something directly to the player in the field, do it directly to the player in the field. Do it once and then go away. We've got the red dot sprite set up for it. We're going to just give it that collision. We still need to change the way we're setting up the collision groups, but that should be fine. So we have that collision. We're going to go into behavior groups, and we are going to add behavior group, and it is only going to contain the one behavior, which is collision points. There. You want to change it so you don't have to give a behavior group, that you just give a list of behaviors. I'd originally thought hey, we could reuse the behavior groups, but we're probably never going to do that. Okay, so we've defined that. We have an entity called point test. We have a type of collision points, and then we have a group for point test. And point test has a red dot sprite. Okay. So when we are setting up collision logic, then we need to make sure that we get the right collision types. Type 8 needs to collide with type 1. Collision mask, okay. If entity category points. This is where I could return a composite of multiple things. Entity category player. So enemies seek to strike the player. When a monster runs into the player, the monster collides with the player. The player does not collide with the monster. When a bullet collides with a monster, the monster does not hit the bullet hits the monster. This is collision masking. Like right here, the player collides with nothing. If we go with the idea of a weapon that vacuums in points, then there will likely be a special type that is like a suction type, you know? And its goal is to pick up items, like item grabber or something. And that object would strike points. And it would go about differently, or some other way. But this is how we're structuring it, because we see that in the collisions. It's the points strike the player. And so they view the player as the target. Okie doke. Have that in place, so now we should be able to add another spawner that will make those things. Once again, in real time, showing why I want to do these in a CSV instead. Test around player. This will be entity of point test. It will spawn right away. We're just going to do 1 sec per second. We are going to run this, and it's going to work first time. Let's make it so we can clear these guys out real easy. We should be getting those things already. Oh, I know why. They are not set to spawn. The spawner exists, but the spawner is not being used because we're not loading it into level 1. So there is spawn list for level 1. Loading. Good. Oh, there they are. They shouldn't be moving, but they shouldn't be hurting us. Spawner point test around player. Which gives us an enemy of point test. Enemy of point test has... Oh. Group point test. Run through Godot this time. Just cause. Load it. Load it. Load it. Emit death. We have a couple of our little red bubbles. Let's remove some of the death so we can take some damage. Suffered some harm. Resume death. Power-ups. Boop. Health back. Health back. There we go. We now have a very basic scoring mechanism built in now. Well, a very basic pickup mechanism. If you touch a power-up, you get it. And currently, the power-up gives you HP, but that's a proxy for us tracking score in some way. So we can set up a message for, get point. And it can be like, that message type has a type of point and a number of those points. Then, instead of them appearing as arbitrary spawns that way, we can make a type of event or a marker, kind of an on-death kind of marker to incorporate that says, like, when a blob is killed, flip a coin. If it comes up heads, drop a token. Go pick up token. Yeah. Check a couple of things here real quickly. Okay, we're going to be right back, and then we're going to resume. Just a moment, please. So we have our game over screen. We have the ability to pick things up. Like I mentioned, I don't think the player object should be the one keeping track of the points. I think the points should live somewhere else. So let's keep the points as is. They exist as a separate spawn, you know. We're going to switch you back to 1 so that it's a little easier to maneuver around. So we're going to create a new type of message. I'm going to call this a point message. And it will extend nothing. behavior message. We create them with whatever variables we want. Okay. We do that in entity. Let's look here. Okay, we created a public static class for that. Ultimately, this probably shouldn't be here, but is going to be here for now. Public. Just going to call this XP for now. We want to do that. An actual uint, but we refer to it using the right values here. Yeah, point message. Uint. Point message takes a uint point category. What kind, how many? There we go. Now I can make a point message. And I think this is territory for a service. Like an actual thing that everything wants. Kind of player inventory, but kind of not. So we're going to make a new thing. I think it's actually part of the game. I'm going to give it a points folder here. Partial that. actually be a point message at that point, or would we be sending an explicit event? I think it's that we're sending an explicit event. Let's go to our entity manager, change category, get random. Yeah. It is not a point message. Entity. So we do have a collision points, but we do not actually have a point message. We are going to keep that though. And we're going to get rid of the point message. Like that. Okay. Like dictionary, int, and I'm naming them kind of generically because a point is any number of things in this case. You know, you have 5 sprockets, a blueprint, and 23 coins. So we're going to add points. We get a category and a count. And then, let's see. Points dot contains key category. And value to set is plus equals dot at the value. Have a clean way to do this. Let's do it this way. If it's already there, we get the value and we're effectively going to update it. Which should work. Let's do that public for now. Gives us our point tracker, which we are then going to need a scene for, I believe. Even our entity manager, I believe, has a scene. Base entity manager. We are going to make a base point tracker. The regular one will have that. This will be an implementation of a point tracker. So the reason we're doing this is again because I have a way to swap out different things here. So I have the basic definition of a player state, and I have the one that we're probably going to use for the game. But I can make other ones, and we could see that in Collision. I've had several iterations that I'm keeping around for reference, but we're using, I believe, node-based now. I'd have to check from a naming convention which one we're using, but we have a particular one that we have socketed. At any time, I could swap a different one out. And the core intent of doing that is so that eventually, in an ideal world, I could add unit tests. By running the program with a different run param, I can change which set of resources to use. So I could create a series of testing resources and run them to target individual bits of code. I could also make tests that target smaller things, but there's quite a bit of the code that relies on other things existing, that the game should be run, kind of stuff. Okay, and we are going to get our logic here. Pull this over into this. Say override, but it'll complain about that because abstract. So we have add points, it handles add points. Technically, add points can remove points. This is fine. And this is going to give us a way to extract the points from it. The expectation being that we want to get all of the points. This will not get the actual point values, I'm sorry, will not get the actual dictionary. It's going to return a copy of it. Duplicate. Might have a copy constructor. City collection. Yes. Okay. Let's copy that. So if we need the whole collection, we'll call this get all points. This will just get one value. Earn 0. Stop. Try get value. Category out to return. Rat run. There we go. So we can get all the points. We can get a particular value of points. So now we need to make a scene for base point tracker. Which lives somewhere. Points. Create a new scene. Base point tracker, and it is just going to be a node. By default, the point tracker has no presence. I do need to change that in several of them. There's no reason for a lot of them to have a position. Like the player state is hovering in the void. It does not need to be at 0, 0 or anything like that. Same with a lot of them. By removing position, we remove any need for it to calculate where it is or deal with where it is. Base point tracker has a script called base point tracker, which we load up. And then we can go up to our startup resource. Entity manager, our world state, our UI. Point tracker. Here we rebuild. Since we've set up a new export, we can now go to the default starting resource, and we will have an empty slot for a point tracker, which we will fill with the base point tracker. So now everything has access to this little guy. Which means in our services, where we have all of these elements that are universal, have a world state. Didn't want to run this for C#. I wanted to run it through Godot. Kind of living dangerously with how I'm doing this, because pretty much the entire structure of my program is entirely in my head. And one day, that's going to bite me. Ooh, like that. Game contains nothing. Game did not load all the other stuff. Why did game not load all the other stuff? All the things are properly there. If we go to game, did it mess up here? Maybe? We'll check. We may have knocked out one of our setups here. Camera exists. It should be there already. We shouldn't have an update until the camera exists. Okay, Repair Game Services didn't like something. Okay. Okay. That is because over here, point tracker does not extend node. It must be a node. Using Godot. Partial after abstract? Doesn't need to be abstract, but you know, there we go. Wow. Just gotta Press some buttons for someone here. There we go. How distasteful. Loading. Loading. Start. Okay. Now we have a player state. We're now going to get our point tracker and add it to the game world. Other things may need it. Wait. I don't think we actually need to add it to the game world because we've set it up here. Okay. It is part of services, but we don't need to add it to things. And that's one of the things that I have to watch out for, is whether we need to actually add them in. We may still do that, though. We'll do that for now. Add child. So, like, the entity manager doesn't really need to be a child, but by putting it there, when we exit the game tree, it hits all of these objects and removes them. So we'll make new ones each time. We can still interact with them as unique entities, but we don't have to. All right, so now that we've got that, we are going to go into our behaviors and get our collision points. So instead of healing the player now, we're going to do services, point tracker, add points, and we are going to say point category.xp1. And we will go into our game. We have label stats. Dot point tracker dot get. Actually, or each value pair new int values pairs in services point tracker get all points. I'm going to say for each of them so that I can test doing more of them in a moment. Pairs in that. Say stats.text plus equals that. It's actually going to be pairs.e.toString reorganize this a little bit. For each one, we're adding the key value pair. Does it explode? It did. Point tracker is null in services. Oh, we haven't set it. Core. In core or elsewhere? Well, thank you, JCR. I appreciate it. I appreciate it. Thank you for the super chat. I think the pop-up worked. My alert system is custom. Multi-streaming presents particular challenges that things like stream elements don't handle well. But again, I appreciate it. Okay, why this no work? Point tracker is not being instantiated. Prepare the game services. That's generally the goal. We every now and then we'll play action-y games. There's Monster Hunter World or Monster Hunter Wilds again in the near future, likely. Play a lot of things like Observation Duty as well, but otherwise coding. Trying to get our game working. Why does this not work? Where did I put the stuff that makes it work? Game, we add all these children. I am adding the point tracker, but the point tracker doesn't exist at this moment. World map to update. Oh, right there. I forgot about this. A service has to assert, when it is created, it asserts that it's the one. Okay. Boy, point tracker. Point tracker. Is point tracker is equal to this dot name is equal to point tracker. This registers it with the services. As soon as it's created, it becomes the one that services reference. This sets the name of the node in Godot so I can tell it apart. Loading. Starting. Okay, Let's just set up the death field here. We'll grab some of those points and see if it works. Might be hard to see because the number will appear near my right ear. Let me move around a little bit here. There, not there. Over here. There we go. So that 1, 2. So if I run over another point, it should go to 1, 3. For every time we touch one of these little red dots, we should be getting another point. There we go. Now, the point tracker only cares about how many there are. It doesn't care what they are or what you're going to do with them. If subsequently something consumes those points, then we can adjust the points accordingly. I might add an explicit set points operator on the thing. And we are going to have to watch out for asynchronous behavior as we go along. Since we're using dictionaries, and as we saw, if you try to add to a dictionary multiple times in different threads, it doesn't like it. It doesn't like it. Okie doke. Okay. Let's check something here. We have points working now. This is good. We have points working. That is a lot of our core loop. Let's add something to the game over screen to show that. So we need a label in game over. We also need a way to convert those to strings. Like, what are we calling the points? Wonder if that's something that we should load into data files as to what we call them. But for the time being, static string. I mean, we can have an interim for giblets here. I always have fun with, well, it always bothers me. So, there is a faction in the, there's a group amongst people that have played shooters and whatnot, that refer to the splattered bits of an enemy in some games where, you know, defeating them makes them erupt into chunks. They refer to them as gibs. And the GIB there is short for giblets. So it's gibs. It is the same kind of folks that insist that a dot GIF should actually be a dot GIF, because that's what the creator described it as. We'll also say that giblets should be pronounced giblets. Pick a lane. Though, frankly, we could solve a lot of that if we would just decide which sound J makes and which sound G makes, and then use those in words. Oh, but this is an imported word. This is an adopted word. Change the pronunciation. Like, if it's a proper name, fine. You have to know where that proper name comes from. But if that letter isn't pronounced that way in your language, then make a version of that word that matches that language. /rant. Okay, so then in our game over screen, we're going to add a label. All this is temporary hacky stuff. Pop you up here. We're going to go to our layout, container sizing. It is going to expand to fit. Label is going to have text that is points there for now. Label settings, line spacing, that's fine. Font, give it a actual size of 60. Well, that'll do. We'll give it no text for now, though. There will be issues with that in just a moment, but we'll deal with it. Okay, then our game over screen needs a new export accordingly. All these screens that I'm making are kind of hacky interim things. Label. Export that. Save. Godot side build. Points. We give you here. Placeholders, yes. Nothing could possibly go wrong from that. There's quite a bit of this code that we're probably going to end up burning down and remaking on the regular. Public override. Process. Oh, we want to be able to prefix it. Okay. For each. We need to put that in our HUD update. We're going to take that same thing that we put in HUD to update and instead put it in our... Actually, we'll put it in both places. Yeah, not like this is meant to be permanent. If length 0, character, don't put that there. So we're not going to do that. We are going to do points. Bring that. So this will be on our game over screen. Do points here. Move this here to make it easier for them to hit us, and then we hold still. Is there a way we can weaken these further? Make them real wonky. So ultimately, what I should be doing for each test is going through and changing the spawn rate of the blobs. Like, I should do that before we enter the test. Okay, that should have updated this part here. Oh. No, it shouldn't have. Because I never told it to. Now I've told it to, which gives me an opportunity to accelerate the test. Here. Spawn 10 of them every second. That is a thought pattern to get into with programming. Is it only does something if you tell it what to do that, and it will do exactly what you told it to do, even if you don't understand what you told it to do. Okay, first off, we're going to put horribly kill them all mode on so that we can get the points out of there. Okay, we have 2 points of type 1. We're getting a lot of explosions happening in the same spot, and I'm curious as to why we're always getting... Oh, no, okay, it's just we've got a couple multi-collisions going on here. Two giblets. Now, we would likely visually display this. We would have better control over the layout of the screen. We would do something with the rest of the screen here. But the core of our logic is in place. We now have a way to generate and obtain and reference score values, which means we have access to this during the game. We have access to this on the score screen, all kinds of stuff like that. So we can continue. The player is gone because I don't have actual continue logic built in. But the player still entirely functions while this is going. Let's kill that frame rate for a moment, just to show folks what we can do. Let's make it extra weird. We are going to add bounces. So there will be an extra several bounces. They will move in a wave pattern as well as circling out. And they're going to try to track a random enemy while they move. Let's turn off the explosions so you can actually see that. The explosions thing is to trigger an explosion every second along the path of the yarn ball. So the wave pattern is greatly distorting their movement here. So it tries to move in an S-curve. That's going to throw off the rotation. Additionally, the yarn ball is dragged towards an enemy by this value here. So if we remove the wave pattern, we should see kind of a almost kind of elliptical orbit start to show up, because it's going to keep trying to curve back to the player's position, but it will also drag the yarn ball towards an enemy. So you can see like a series of overlapping loops. Then here's if instead of tracking an enemy, we're going to use random direction. So when a yarn ball appears, we kind of roll the dice and pick a direction that it's supposed to move in. That direction is going to be applied in addition to the rotation that's happening. So we're going to get real distorted movement happening. Some of them are going to seem to slow down. Some of them will seem to speed up. But you can see some of the randomization. Some of them are just whirling off the screen really quick. But we're getting similar to the tracking because it is distorting the circle. Take that out. I don't know what spiral in does right now. I don't know what I have it set to. It seriously messes it up is what it does. Nyom. I think I know what's happening. But this is unexpected. I'll have to look at this further. It shouldn't be accelerating that much. But I'm pretty confident I know why. Again, the math for spiraling is complicated. But this tells me there's a problem with how I'm doing it. So here's another fun one. We have a testing gate, and this is after so many seconds, it will let the rest of the function fire. So the yarn balls will initially emit in little clusters of 1. And then after a few seconds, they will explode out into a whole bunch. But if you watch, they try to move back to the player as they orbit. That's why we're getting this little starburst pattern, is they're trying to orbit around the player, but they're appearing at an origin point further out. So it has to kind of try to course correct. If we change it so that there are 3 to start with, we get a similar behavior, but it'll be scattered around further, assuming it can get through the enemies. But yeah, we're making progress. We're making progress. Check a couple of things here. Got a couple of screens. Is that not working? Did it actually not run that? That would be annoying. Okay. Well, tall format wasn't running. Sorry, folks. Apparently, you have to press the button and stare at it for a few seconds before it registers. So for those that may be encountering tall format right now, we've been going for a while. Oopsie. Let's see. Okay. For our next objectives, gotta think on this a little bit. We do need to add... We're at a point where more visuals will be necessary. We've got to change the data file to be a CSV so that it's easier to edit them, because there's over like 150 some files that all my stuff is scattered across. So I need to clean that up. I'll want to find a format that I can put them in that Godot isn't going to pitch a fit about. Godot sees a CSV and it's like, I need to translate that. No, you don't, Godot. No, you don't. So we'll need to do that. We'll need to look into how we want points to work, but that's kind of a longer-term gameplay thought. At the moment, their general function is okay. Looking at it, like if we have points on the field, say we have them the way they are, we would add a behavior for the slimes that upon being removed, they trigger and say, okay, what are the chances that I drop XP kind of stuff. We've got that. I would like to have a mechanism for passing arbitrary parameters into the construction of a behavior or similar when we are creating it. So when I load up a entity from my files, I would like to have a system for saying, and here, set the extra values. Or set additional values. What I would want to use that for is I don't want in the... Like, I don't necessarily want a JSON file for every permutation of deal damage. Like, if a blob deals 3 damage, I don't want to have a file or a line item for deal 3 damage and then have to reference it in the blob. You know, if it's a deal 3 damage, I don't intend to ever change deal 3 damage. But we'll have to see how that goes. There's also just the way I'm loading, I have concerns again. The async loading can run into problems with subsequent loads. I could probably get away with it by having interim files. Like, while it's loading, we have a ghost dictionary that everything is loading into. Once it's done, we then take that ghost dictionary, iterate over it, and put it into the actual one. That way, and when we create the ghost dictionary, it is a copy of the real one at the startup. That way, if we load a subsequent modifier file, then we don't have to worry that... Oh no, we would still have to worry about that. Oh well. But that's why we need to think on that, because the way that I've changed it with the asynchronous loading, we now run into we have that we can load without specifying the order of loading. I don't have to worry that all of the behaviors have to load early, before I load entities, and all the behaviors have to load before behavior groups and so on. But I've now created the problem that when a mod loads, if that mod references a component inside of itself, like it overrides an X and an X depends on Y, and it overrides Y as well. If X and Y already exist in the files, then when X loads, if Y hasn't been overridden already, X will contain the old Y and not the new Y, and that's bad. And would be hard to catch, because it would still be valid as far as the loading would be concerned. We would need to have a way to specify, to keep track that this is an override to the values. This is a new thing. Oof. Big oof. That would also be the case for all the base files. Thinking on it, that would be the case for the base files. If I override what a Y is supposed to be, and there are things in the base files that already loaded Y, then we have a problem. We need a way. We need to reconsider the way we're loading. Okay. We still have a lot on the horizon, but this break today, or this pattern today of getting in there and getting more gameplay in place, getting more of the flow in place, I think was good. Now we are going to need to have ways to deal with those points more and more, to solidify some of that system and get some of the variations in place so that we can keep iterating on the core loop while we continue to work on the systems under the hood. So yeah, careful, Molly. Careful, Molly. There you go. Molly likes to walk across my soundboard. Molly's paws are unerringly accurate at muting things and striking buttons that will cause sound issues. Hey, Blocker. Welcome. We're considering where we need to go next, and one of the things that we're running into today, as we are wrapping up here, is that our loading structure, I think, needs to be adjusted. Again. That's a good opportunity. Let's switch over to the kitty cams here. Molly has joined me for snuggles. Let's see. Sky is looking around in the play area. I wonder what he sees, because all of the cats are accounted for otherwise. We have Mason, Sherbet, and Sammy on the bed, Sky in the play area, and Ember in her spots. Molly is on my lap. So I wonder what he's looking at. They are little sweethearts. They are little sweethearts. But yeah, I think we made a lot of progress today. I'm happy where we ended up. I do need to think on that file loading thing, because while I like the fact that we have it asynchronous as a whole, we may need to actually loop back around and say it needs to load in a particular order. Like, that has to be true. But can we come up with a different way to load them? Can we set that up differently? We'll have to deal with it. We'll have to deal with it. We'll have to think on it. But we have new gameplay flow in place. That's good. For the rest of the week, schedule is up. Tomorrow we have more observation duty. We're going to kind of rotate back and forth, back and forth. Plan for the weekend is to have a double coding both days there. Let's see. I've had a variety of cats. You can see all but one of them over the course of my old streams. Shameless plug, watch my old streams. My oldest cat was Tom. He was the remaining Maine Coon sibling since I started streaming. His brother Bob passed before that. But he was a giant lummox. Maine Coons are huge. There are folks that breed them to be small, and I kind of wonder why you're doing that. Let's see. There was also Rorschach and Weasley. Rorschach was a big old tuxedo. So you can see Sammy, who's a little tuxedo there. Rorschach was 75 to 100% bigger than her. Yeah, Tess, a toy Maine Coon is kind of like a toy Great Dane. It's like, okay, so it's a regular-sized cat with long hair. We have those at home. Let's see, Rorschach and Weasley, they got there's a particular kind of infection that pretty much all cats carry. There is always a chance that it mutates, or that they get a mutated version, and if you get a mutated version of that, it's lethal. But yeah, let's see. Tom was like around 20 pounds or so. His brother was bigger than him. Tom was fluffy and kind of chubby. Bob was not. He was a brick house. He was all muscle. He was also an incredible coward. The slightest noise would have him cowering under the bed. Yeah, it's my perspective for the size of animals is completely busted. My family had a Great Dane growing up, and I raised two Maine Coons, so everything is a small animal to me. Like, you've got to cross into farm animals before it's like, oh, that's a sizable creature. Ember on camera there is very tiny. You can see Sky standing next to her. He's kind of a medium-sized cat. Mostly fluff, but he's still a big cat under the fluff. Ember is like half his size. She is itty-bitty. Smallest by far of all of them. noticeably smaller than Sammy and Sherbet that you can see on the bed there. She is my second oldest cat. Since the additions of the others, she has increasingly become a cranky old lady. That is... Always expect an animal is going to be bigger than you think it'll be. The Great Dane I mentioned was the runt of the litter. It was expected that he would be very, very small. And while he was much smaller than his father, who, like, his head was, like, at 4 feet or so, like, standing on all fours. He was taller than average human male if he stood on his hind legs. The Great Dane that we had was the runt, and he was smaller than that, but he was still a very, very big dog. He had the classic puppy growth pattern where he started out able to eat into and then fall asleep in his food dish. And the little photo album we have of him could have been a comical flip book, because every picture of him had him bigger and in proportion to a dog bowl in about the same position. So it went from tiny puppy with gigantic paws sleeping in dog bowl to big head of dog bigger than dog bowl. But yeah, so tomorrow we're going to be playing more observation duty. We'll see if we can get through the factory level. That is the most complicated observation duty level I have seen in the entire series. Then on Saturday and Sunday, we will proceed into more coding. Hopefully by that time, I will have an idea of where we want to go next. But we'll see. We'll see. But yeah, I hope everybody had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, all that stuff. It helps the platform. It helps me grow on the various platforms. You can find VODs for the streams on Twitch, for the Twitch streams, as well as on YouTube. If you'd like to consider financially supporting the channel, you can do so through the methods available to each platform, as well as through Patreon and Ko-fi. Links to all the things are in the link trees on my profiles. But with all that said, I hope the rest of your day is good, and I'll see you next time.